Hello folks, welcome to today's video. We're going to continue with enlargements and reductions. So today we're going to talk about reductions. So again, here's our little outcome. Draw and interpret scale diagrams that represent reductions. So in the previous video we talked about enlargements and how we find scale factor, and we use scale factor to find new dimensions and so on. So today we're going to talk about reductions, and it's going to work in much the same way. So for example, here's my original picture, my original diagram. Here's my reduction, right? Reduction meaning it's getting smaller. So to calculate the scale factor, again, we know that to find the scale factor, we use the dimensions of our scaled diagram divided by the dimensions of our original diagram. So if we looked at our two ladybugs here, my scaled diagram has dimensions of 2 centimeters. My original has dimensions of 6 centimeters. So we'd say that the scale factor is 1 over 3, or 2 over 6, which simplifies to give us 1 over 3. Pairs of corresponding sides all have the same scale factor, so we say that the lengths are proportional, right? So if we have the same scale factor all around an object, that means that those two objects are going to be proportional, meaning that whatever happens to one side, the same thing has to happen to all of the other sides. So if this ladybug's width has a scale factor of 1/3 to get 2, right, then its height would also have a scale factor of 1/3, and each of these little dots would have a scale factor of 1/3, and so on. So remember, scale factor is less than 1 if it's a reduction. So notice our scale factor here was 1 over 3. So 1/3 is less than 1. It's going to be more than 0, but it's going to be less than 1. If it's a reduction, and if it's an enlargement, it's going to be greater than 1. So where is scale factor reduction used? Well, we see it when we talk about any kind of toy that represents some real-world object, some life-size object, right? So like Hot Wheels, for example, are scale factors. They are reductions of regular cars. Barbie is a reduction of a human, right? Maybe not quite, but there are dolls that are reductions of humans, right? Blueprints for a house, right? Houses kind of shrunken down and onto a piece of paper, right? That is a reduction. Okay. So let's try a few of these questions. So here we have a question. A photo has the dimensions of 44 by 36. And what I find can be helpful with these questions is to draw it. Right? If you're ever not sure where to go next, it is always a good idea to make a diagram, right? That can help us kind of figure out the next step. The photo will be reduced by a factor of 4. What are the new dimensions? So again, our equation here is dimensions of the scale diagram over the dimensions of the original diagram will be equal to the scale factor. And again, reminder, scale factor is less than 1 if it is a reduction. So let's take a look at this question. It's saying that it will be reduced by a factor of 4. Well, 4 is not less than 1. So what that means is my scale factor here is actually 1 over 4. Right? So what we can do is to find my new dimensions, right? My new side lengths. What we're going to do is we're going to take my old side lengths, or my old dimensions, and we're going to multiply it by our scale factor. There we go. So for this 36, right, my new dimension is going to be equal to 36 multiplied by 1 over 4. And a quarter of 36 is 9 centimeters. And the same thing for the 44, right? 44 multiplied by 1 over 4 is 11 centimeters. So what that means is that my new photo is going to have dimensions 9 by 11 centimeters. All right, let's try another one. A photo has dimensions of 35 by 20. The photo will be reduced in size to 10 centimeters by some unknown. What is the scale factor, and find the missing dimensions. So what that means is we have to try to find our few different things this time, right? So now we have, here's my original, here's my scale diagram, and what I know so far is that this is a 35 by 20, and this one over here is 10, right? And I'm going to assume that the first dimension given matches the first dimension given. Right, so step 1, we have to find our scale factor. So again, scale factor is equal to new dimension divided by old dimension. So in this case, that's 10 over 35, which if we reduce is 2 over 7. Okay. So that means my scale factor to go from this diagram or this image to this one is 2/7. So then what I need to do is take this 20 and multiply it by 2/7. So to find this missing side length here, let's label it x for a second. Well, x is going to be equal to 20 multiplied by 2/7, which is 40/7. 40/7, or 40 divided by 7 is 5.7 centimeters. Okay. All right, let's try one last one, and then we'll leave it there for today. So a sheet of photocopier is 8.5 by 11 inches. A student sets a photocopier to reduce the page by 75%. What are the dimensions of the scale diagram? So it's not always going to be fractions. It's not always going to be reduction of 4 or 8 or whatever. Sometimes we'll talk about percentages. So we have to know how that works. So how do we deal with 75%? Well, first we have to realize that 75% is actually equal to 0.75 as a decimal. And there's our less than 1, right? So to find our new dimensions, what we're going to do is take my original dimension of 8.5, and we're going to multiply it by 0.75. And take my original dimension of 11 and multiply it by 0.75. And let me just quickly grab my calculator here. All right, 8.5 times 0.75 is 6.375 inches. And 11 times 0.75 is 8.25 inches. All right, so there are the dimensions of my photocopy. All right, so that is it for today's video, and I will see you all in the next one.